Hello, my friends. So, day 2 of jury duty. So, I wanted to make sure that we are plugging right along with what we need to be learning. So, I am going to tell you why pizza is, in fact, the ultimate food. Okay. So, this is called our pizza macromolecule input chart. Okay, and what's your job during an input chart? It's to listen and pay attention. It's the hardest job in history. Okay, but I know that you can do this. Okay, so of course, first thing we're going to start with is this lovely pizza. Who does not love pizza? Seriously, it is the bestest food ever invented, at least in my mind. Okay. The first macromolecule that we are going to talk about is called a carbohydrate. Now, you've probably heard of these words before in health class and things like that. Okay, so this should be really nothing new to you other than we are looking at them in kind of a different way. Okay, so an example of carbohydrates is pasta, my favorite. Okay, so you would get carbs in pasta. You would get carbs in bread and grains, like so. Okay. And so, what we're going to do is we're going to use our imaginary zoom in function. So, I would ask you, well, what is bread and pasta made out of? And you would say grains. That's right. Okay. So, grain. So, notice how we're going from, and of course, the crust of the pizza has carbohydrates. Because that is a bread type situation. Now, what makes up bread? The grains make up the bread. So, what makes up grain? Okay. So, here we're going to have to zoom into our molecular level. And what they are called, this is called a monomer. These are the things that make up grain. And we are at the molecular level. Okay, so the monomer is a building block. Okay, so monomer is a building block. So, molecularly speaking, a monosaccharide is the monomer of a carbohydrate. Okay, monomer. And that's important for us. We're going to need to know that. And specifically, now we're zooming in even more. They look like little hexagons up here. Here is your specific hexagon. This is a monomer of a carbohydrate. At each of these little intersections are carbons, and then they have hydrogens and oxygens all around. Okay, so the monomer of a carbohydrate has carbons, hydrogens, and oxygens. Okay, so we're going to put that right there. We are zooming in to the molecular level of a carbohydrate. Okay, so that is our first macromolecule. Our second macromolecule is called a lipid. Okay, another name for a lipid is called a fat. Okay, they are interchangeable. So we can find fat in a couple of places. Anybody ever eat donuts? Ooh, they are high in fat, but they are so yummy. And of course, in our bodies, we don't judge, okay? But fat is used to insulate our bodies, and um, and we have to have it. We have to have fats. Even skinny people have fats in certain places, okay? And that's a good thing, good healthy thing. So, um, let's zoom in even further, okay? And in fact, most of our cells, not gonna say every, almost said every, that's never a good thing. Okay. Most of our cells in our body have this thing called a lipid bilayer as the cellular membrane. Okay. So this is fat. Those molecules, these orange and yellow ones, those are fat molecules. And they make up every cell membrane, not every cell, most cell membranes in our body. Okay. And so here we have a lipid bilayer. So I know I can hear you wondering, well, Miss Smitha, what's the monomer of a lipid? Oh, what a great question. I'm so glad you asked. And in fact, this also has a monomer, and it is called so we're going to go here. Monomer is a glycerol plus 3 fatty acid chains. I didn't name these things. That's just how it works. Okay, the glycerol is this orange part. The fatty acid chains are these yellow parts. And they make up our cell membranes, and super, super, super useful. So let's zoom in even further. And here we go. Again, I see a whole bunch of C's for carbon. See a whole bunch of H's, hydrogen, and there's some oxygens over here. Okay, so this is also made up of carbon, hydrogens, and oxygens. And you have just met our second macromolecule. Oh, I know, you can't wait for our third macromolecule, right? Okay, our third macromolecule are called, let me see this, proteins. Okay, and we use proteins in our bodies. They make up muscles, hubba hubba, right? And how we get those proteins is through meat, eggs, nuts, beans. Okay. Oh, cashews. Whoo, love me some cashews, right? Okay. So that's where we can find a large amount of proteins. So we'll slow down, guys, slow down. The monomer of a protein, yes, I know you're so excited, is called amino acids. So a protein is made up of a string of amino acids like so, and they can be broken down into individual amino acids. So let's write that on there. So our monomer is amino acids, but we can zoom in even more. And here we go. These are the chemical structures of amino acids. So I see some carbons, hydrogens, oxygen, but look, there's a nitrogen. There's a nitrogen. There's a nitrogen. So now we have carbons, hydrogens, oxygens, and nitrogens. Interesting. Okay. And our last macromolecule are called, oh, that's a sharp, that's a highlighter. I don't want a highlighter. Okay. Our last one is called nucleic acids. And these are, in fact, my most favorite molecule. And let's talk about why. Because nucleic acids are DNA, and DNA is, in fact, my most favorite molecule. And we're going to talk about that in a minute. And where you would find DNA would be in the middle, in the nucleus of plant and animal cells. So here we go. I'm going to do that. Okay, in the nucleus. And we're going to zoom in even further. And the monomer of nucleic acids are nucleotides. So let me show you how that works. So on this side, you have a whole bunch of nucleotides strung together. They can be broken apart, and those are called nucleotides. And we can zoom in even further. And here we go. Here are the chemical structures of our nucleotides. So notice nitrogen, hydrogen, those things right there, those are carbons. Here's an oxygen. Okay. And so now, look at this. Can you guys see that? What letter is that? Can you see? Right there. That's a letter P. Huh. Interesting. Super, super interesting. So that's made up of a carbon, hydrogen, oxygen, nitrogen, and phosphorus. I wonder if I've heard those before. Interesting. So we can find carbohydrates in the pizza crust. We can find lipids. There's lots and lots of fat. Look at that grease on that pizza. Okay, lots of fats in there. We can find protein. See, we got sausage, pepperoni, that looks like chicken maybe, and some cheese. Cheese is actually really cool, kind of has a lot of everything in it. And for nucleic acids, anything that has a plant or an animal cell in it, you are consuming nucleic acids. So the crust are plants. That's from wheat. So there's plant DNA in here. The pepperoni, the sausage, the chicken, those are all from animals. So those are from animal cells. So they have DNA in it. So almost everything we eat has DNA in it. Anything that we put in our bodies. Okay? Now, how we're going to remember this, because this is a lot to remember, right? Yeah, but that's okay. We can do it. So, how we remember this is carbohydrates are a CHO. They are made up of carbon, hydrogen, and oxygen. Now, lipids. Lipids are also a CHO. But do these CHOs look the same? They totally do not look the same. Okay, so even though they have the same molecules in them, they are completely different. Okay, but they're also made of carbon, hydrogen, and oxygen. Next, we have our proteins. Our proteins are called a CHON because they have carbon, hydrogen, oxygen, and now we've added nitrogen. And our nucleic acids are called a CHONUP. That's how I say it, CHONUP. Because they have carbon, hydrogen, oxygen, nitrogen, and phosphorus. So when I'm talking about the macromolecules, I'm going to refer to them as CHO, CHON, and CHONUP. Okay, what are our four macromolecules? CHO, CHON, and CHONUP. We're going to get used to that. All right, thank you for watching.